Hello, everybody. Can you all hear me fine? This is also a good time. If you can use your reaction just to let me know that you are there. Thank you very much. It's kind of tough to stare at the screen sometimes. Not sure, if you're speaking to the black abyss or if people here. Yes, feel free to use the chat function on Zoom. Throughout the talk, our wonderful staff members will be monitoring the chat. So, and bring whatever if you have a question or anything like that. Yeah. Once again, feel free to pop into the chat. So let's get started here. Can you all see my screen? Okay. Sweet. All right. Okay. So welcome everybody. So let's get started. Thank you and welcome to our first workshop, or first of hopefully a continuing series of different workshops on technology topics that is essentially sponsored by the web and mobile program at Langara. My name is Jason Madar, and I will be presenting tonight on the topic of AI. I really like the topic, demystifying AI. I find that with technology, a lot of the times, if you're not if you don't understand how it works behind the scenes, sometimes it can be intimidating, and sometimes it can be like just a big unknown. So hopefully tonight, with the time that we have, I'll be able to present to you, some of the behind the scenes workings of how AI works. I probably don't need to tell you what well, I mean, I will tell you what AI means, but throughout. But I'm sure that you have heard of the term artificial intelligence, through just through our popular media, like through the just popular culture. Like it's AI is just everywhere. So, but before that, just tell you a little bit about myself. My name is Jason Madar, and this is my LinkedIn, so you can just go visit there a little bit. LinkedIn is pretty much the only social media platform that I use, so I'm just going to pop this into the chat. So if you like, you can. Actually, this is YouTube, so you don't follow and subscribe, but you can probably connect with me through LinkedIn. Right. So that's me right there. I am the coordinator for the web and mobile program at Langara. So I manage the program itself, as well as I teach in the program and also in the computer science program. So if you just scroll down very quickly, I don't want to go through every single thing, but like I have been at Langara for a good number of years, but I've also been in industry doing various work, including quite a few of these kind of founders and technology officer. A bit of an entrepreneur, but lately I've just been kind of helping out people. If you have a startup, and if you need advice, I do help out as well by giving advice and that type of thing. And lately, pretty much all startups or most startups, they have a bit of an AI bend to it, right? Like all. So I'm fairly familiar with that. So hopefully I'll be able to share some of the behind the scenes workings of AI. But my full-time job, once again, is at Langara web and mobile program. Just a tiny little bit about the program itself. I'm also going to plot this into the chat so you can. So for this particular program, it is what we call a post-degree diploma program. So this is okay. Well, first of all, I'm kind of old, right? Like I'm so I've been around for quite a while. I've been both in academia and in industry. I gotta say, that this is one of the best program that I have the pleasure, or I have the pleasure of being involved in, right? And so all our students, they all have degrees, and they all want to transition into technology. So what I find is that our students just pretty incredible in terms of their motivation, and just really great to work with. So and the program is very focused, and I know that we have quite a few of our faculty here tonight, and you guys, like, we just the best team that I've worked with. So it's just a wonderful environment. We're always keeping up to date, and we're always uh, al- al- always trying to provide the best for students. So this is a program website, but if you look at the events, if you're a guest, I would really highly encourage you, if you're in the Vancouver area, to sign up to take a look at our capstone showcase that's coming up December 12th at Robson Square. So yeah, if you look at this, like, we basically have our graduating students create applications, Dragon's Den style. Always a fun evening where the judges, they are real judges from industry that uh, provide feedback to the apps that our students have been working in their final term. And if you scroll down, you can see some of the apps, and you'll notice that pretty much a lot of the apps have kind of an their AI integrated into their app. So we do try to keep up to date. We try to stay kind of the forefront of technology. Once again, one of the best program, hands down, in the Lower Mainland. I'd say even Western Canada maybe. So anyway. All right. Well, enough about me and about our program. So let's get started with tonight. So what I'm hoping tonight is to give you a very quick introduction of what is AI. We'll see how long it goes. I mean, I'm thinking around 30 minutes, 45 minutes or so, and then we'll have some time for questions if there are any. So let's get started. Right. I always, when I talk about AI, because I'm a little older, I've been around for a while. I like to, show you some older uh, comics, right? So this one is from 2014. I'm just gonna give you just a minute to take a look. So in this comic here, is by the way, it's from a website called 𝐥𝐾CD. It's fairly popular among the among programmers. So because this is a comic strip about programmers, and essentially what this is saying is that this is the boss, right? They're all stick figures because we can't draw. We don't have any artistic uh, talent there. But as a programmer myself, right? So I'd appreciate this. Anyway, so you see this stick figure, that's basically the boss, asking the worker to work on certain tasks, right? And the task here is that, um, can we recognize essentially a bird from the photo? So here it says here, can you take a photo and check to see if the photo is a national park? And it turns out it's a pretty easy thing to do because we have GPS. For those of you who into photo, well, I mean, all of us, when we take photos, even on our phone, automatically there's a geotagging that happens that shows where the photo is taken. So that's a pretty easy task, right? And then the boss asks, hey, can you also check to see if a photo has a bird in it? And then in 2014, the programmer slash employee is saying, well, I'll need a research team in 5 years. Now that is back in 2014. So essentially, the goal of detecting and classifying objects in an image is a very challenging task. And and here the explanation, and this is link to the explanation, but I wouldn't actually go there. But the point here is that it says here for a number of reasons, right? So back in 2014, this is really difficult to do. What is happening right now is that in 2024, right? Today when we're meeting, this is a solved problem. In fact, this problem is considered almost trivial, right? And if you don't believe me, this is the interactive part of the evening. What we're going to do is we're going to solve this problem ourselves right here, right? And so I call this train your own AI, right? So I'm going to share this link with all of you, and then I'll explain what it is. So what I want you all to do is go to this link. Yeah. So what I want you all to do now is to click on that link, and it'll take you to this page. So just give me a hands, give me a thumbs up if you're able to get to that page and you're seeing what I'm seeing. Excellent, thank you. Yeah. So what you're seeing right now is essentially just like the comic, right? The comic wanted to create and something a computer program that can recognize a bird. Here we want to recognize if you're drawing here in this little drawing area, we want to create a computer program that recognize if you have drawn one of these symbols, right? So for example, if I draw, and to draw you just have to use your mouse and click on it, or if you're on your phone you can actually you use your touchpad to do it, but you have to do only with one stroke, right? You can only do this with one stroke. So here, with one stroke, I'm able to draw an outline of a symbol supposed to resemble a lightning bolt. And what is showing here is what the computer program thinks it is, right? And the higher this bar goes, the more likely the computer thinks it is. So right now it is thinking, the computer program is thinking that it's a file folder, while I actually drew a lightning bolt. Let's draw a check mark. And once again, the computer is what we call not working very well, right? Can you tell me, is it working well for you also? And you can if it's not, yeah, you can just say, yeah, so yeah. Please put it into the chat. Yeah. Yeah. So some people say that it's working a little bit. Some people say that it's not really working. Well, I mean, I didn't actually like this right now. This program has not been trained, so you can see that performance is kind of terrible. Because, like, look, I mean, I'm drawing a rectangle, right? I think I wanted to resemble the battery, but it's not actually resembling battery. So I this particular program has not been it's actually it's basically random guessing right now. It's a yeah, so there was no actual program, then it's not really working. All right. Because it's I just basically did a random guess, right? It turns out that if I were to write computer code, and for those of you who are coders, you may appreciate this. It's almost impossible to write code that would be able to perform this task of recognizing what people draw. It's a really, really difficult task. If I were to write code, let's say using what we call if then else statement, right? But we're going to take a different approach. What we are going to do is I'm going to ask everybody's help right now. And what I need everybody to do is to click on this train AI button. If you click there, it will take you to a different page. And in this page, what I want you all to help me with is that if you see the icon over here on the left, I want you to draw on the right what you think the icon should look like. So here I'm going to draw a little file folder, and then I'll let go. Now it asks me to draw a battery. I will draw a battery, right? With a little notch over here, maybe. Now you'll notice that my drawing is really terrible, and that's actually a good thing. I want you to help me, and all of you, to help me draw various um, or different variations of the symbol that you see. So a check mark right here, don't only give me the check mark right in the middle. I also want different variations. Maybe you can put a little smaller file folder up on top here, and that's okay. Maybe if you see a battery, you can draw it like this, right? And that's okay too. And draw fat battery, draw thin battery, like give me all sorts of variations. Are we, does that make sense, everybody? Any questions? Yeah. Okay. So give it a go. Please do go ahead and give me some symbols. So what you're doing is actually you're providing me with all examples of the 4 symbols, right? So you're giving me examples of all 4 symbols. I'll give you maybe a minute to do it. We have a lot of people, so this should be a fairly quick. Yep, it's going pretty quick. Okay, I think let me just double check here, and then I think that I'm gonna yeah, and then I'll tell you to stop. Actually, maybe give it another 30 seconds. So keep giving me keep giving me data, and then we'll stop in about 30 seconds. So let's keep going for just a little longer. All right, let's stop, everyone. I think that this is a good time. I've got enough. All right, so what I'm gonna do right now is show you behind the scenes what's going on. So you're gonna see a black screen. You're gonna see what programmer sees, right? So here is the behind the scenes. All right. So what happened is I'm just gonna run this thing called Python. So what we are doing is we are actually coding the AI live. All right. So train. What you're seeing right now is that so you see on my screen, right? You all of you in the last 2 minutes or so has provided me with 840 examples of all the different symbols, right? All 4 symbols, right? 840 samples. So that's pretty fast. And what you'll see here, what you're seeing here is that I am what in the AI circle, this is called training the AI, right? I take all your examples and I'm asking the AI to figure out what is in common within all those samples, right? Essentially creating, I'll go into a little more detail later, but this is what we call the training process in AI. So because this is a really simple AI, right? I only train it for a few seconds. And right now, what we have created is what you see here is that it's 88% accurate. What does that mean? I want you now to go back to this screen, to the result screen, right? Actually, I want you to it should probably, if it doesn't work, you may want to refresh, but you should be okay if you go back to result screen. But yeah, let's refresh it anyway. All right. So now, can you draw something and tell me if the AI is working for you? All right. So you're all telling me that it's working, right? So let me try it here. I draw a little look. It's completely recognizing the lightning bolt. If I do a little check mark, it's recognizing my check mark. It is doing. I do a little. Okay, this one is not very good, but let's draw over here, right? Over here. Well, it thinks that well, I draw this, thinks that it's a battery, but you can see that it's actually working much, much, much better than before, and that's because you all have provided me with 840 examples, right? Yeah, you guys okay, so you guys didn't draw the file folder very well, right? Right. So if you drew the file, okay, so in this case, it's able to recognize the file folder as well. All right. So what we have just done is that you have all helped me train the AI by providing examples. Now, so what an AI does is essentially take all examples, in this case, examples of various images from each of these categories. I tell the AI, and I'll show you what it looks like. Now, once again, for those of you who are programmers, you're going to be pretty surprised at this, right? You see this thing called train? You can see my screen, right? This thing called train. This is essentially, I'm going to try to expand the screen a little bit. For those of you who are not coders, all I want you to appreciate is how short this is. This is the entire training routine. You see here, it says finish training right here, right? This is what 20 lines? 20 lines of code? 20 lines of code, that's all it takes. And most of this is not relevant. The most important, the most relevant part of the code is these 5 lines. Basically, what I'm telling you is that 5 lines of code with a lot of example data that you have just given me in the last minute or so, together we are able to train or create a computer program that can do something that is almost impossible about 10 years ago. That's what I'm telling you. Right? It's almost magic, isn't it? Right? The 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 technology that allows this to happen, right, is called neural network. And what you're seeing here is, and one example, what you're seeing here with these few lines of code is the example of a neural network, right? All, all it is that we are asking the computer to perform some arithmetic. I'll try to go into a little bit of more detail a little later on, but essentially we're asking the computer to go through some arithmetic or some a set of calculations using the examples, right? And a programmer no longer need to write traditional programming code, right? We can just ask the neural network to essentially figure this out for us, and that's kind of the magical part of neural network, or what we call AI. So when we say AI nowadays, what we're referring to are computer systems that are programmed using neural network techniques, right? And where do neural networks come from? Well, I mean, it came from the 1950s, but it's this guy that essentially made it possible for neural networks to work in the modern day. Anybody know who this is? Right. Yeah. So this guy, his name is Geoffrey Hinton, and he is one of the early AI researchers. And what you saw, those 4 lines of code would not be possible without him figuring out how to make it work, right? So he figured out how to make AI work. And by the way, he is one of the latest. So if you scroll down here, he actually won the Nobel Prize in physics just like a couple months ago, and because of his contribution to AI. You may be asking, hey, how come you like? He's a computer scientist, right? Well, how come he won the AI in physics? Well, that's because um, Nobel Prize does not have a category for computer science, so they kind of have to shoehorn computer science into 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 the Nobel Prize category by um, putting it into physics. So it's a bit of a shoehorn thing. There was some controversy, but in any case, he's um, because of his contribution to AI, and that's what made the demo work just now. That he was awarded the Nobel Prize in physics. Actually, what I can show you is which line actually happened. So Geoffrey Hinton, for those of you who are interested, this line, actually no, this line, sorry, this line is what made it happen. This one, the one that I'm highlighting right now. He basically figured out what goes on inside this one line of code. But this one line of code essentially made it create like it essentially made magic happen, right, with AI, so that programmers no longer need to program, but instead we can ask the masses, right? We can look at data set from the masses, so that we can train an AI instead of specifically program the AI or specifically program a computer system. Um, what you'll notice, just one more thing before we move away from this demo, right? If I draw something kind of silly, right? This does not apply to anything. Let's do it again, right? So this particular symbol right now is not in our training set. None of you actually gave me examples of this, right? But the AI actually believes that it is a lightning bolt. We have a term for this. The term is called hallucination. Anyone heard of the term hallucination in AI before? Just give me a thumbs up if you have. Right, yeah. So I'm sure a lot of you have heard of the term hallucination, right? This is what hallucination is. Our AI is only trained on these 4 examples. However, you can give it some random input and it will still make a decision, right? It is something that is outside of its training data, but but it still pretend to make a decision. So this ability to be confident in the face of a complete error is what we call hallucination. And I know that I'm sure that a lot of you have heard of hallucination, and a lot of you have experienced hallucination when you deal with AI systems. Right? So that's the basic of AI, and this particular type of AI is called what we call technically discriminative AI, or AI that performs classification. Right? You give it a symbol, or you give it an image, is able to classify what that image is. Right? So you can imagine if I give it a lot of bird images, it'll be able to figure out a bird. If I give it a lot of images of stop sign, you'll be able to figure out what the stop sign is. And by the way, this is the AI that is in a lot, if you drive modern cars, right, with some kind of self-driving or system, right, or not self-driving, but they call it a driver assist system. This is the kind of things that Tesla work on, right? Is that all the Tesla cars has cameras. It can see what's outside. You can see a stop sign, and if you see a stop sign, it will stop, right? Because the camera sees a stop sign, the AI is trained, using a lot of these images from the road. So once again, this is called classification, or called discriminative AI. However, the AI that we are all excited about, I mean, we have had discriminative AI for quite a while. The AI that we are all excited about nowadays is not this type of AI, but instead we call them generative AI. Now, generative AI means that the AI is also creating new material out of previous material. Now, what do I mean by that? Well, I have a nice example for you. All right. So here, oh, not this one. Here, this one. What I'm doing here is that now what I'm doing here is that I'm gonna take all of the images that you have given me, and in this case, I'm taking all the images that you have given me, all the folder images that you have given me, right? There's a lot of code. You don't worry about the code, but here's the magic that's happening. So what I'm doing here is you notice that this is very similar to what we did previously, right? I'm also training an AI, but in this case, what I'm doing is I'm training an AI, and it takes a lot longer, by the way. I'm training an AI to create new images based on the image examples that you have given me. In particular, I'm asking the AI to take all of the folder images that you have given me, and I'm going to create, and here I train an AI that's able to produce new images, and I'm going to click on this, and you can see that what you will see in just a few moments is that, look, it is drawing new folder images. Are you seeing that right now? Like these uh, what I've trained an AI to create new folder images based on the folder examples that you have given me. Now let's play around with just a little, just one more. I'm gonna use check mark instead of folder. So I'm gonna change here. I'm gonna tell it to give me a check mark, right? I'm gonna train the AI again. So here I'm training the AI, right? I'm going to run through the same training process. Now you'll notice this training process takes a lot longer than the previous one because training generative AI takes a lot more work than training classification or discriminative AI. So yeah, so it takes a lot longer right now. So now that's done. Let's see. Let's. So now I'm going to generate a bunch of check marks because it doesn't always work. But look, it's generating new check marks for me. These are all the check marks, right? Now, these check marks are not created. The AI does not have any memory of exactly what you have given it. These are brand new check marks. These are brand new check marks that the AI is able to create based on what you have given it. Now, it doesn't work 100% of the time. Sometimes because we are training it like live at this moment, right? Real AI researchers spend months and months and months figuring out how to do it in an optimal way. Well, we are just doing it in a couple minutes. So, it is not truly, it's not going to be super high quality. But what I'm hoping is that you can appreciate how amazing this is, right? And if I run it again, it's going to give me a new set of images that are completely different than the previous set. You see here, this set looks completely different, well, with some being really high quality and some being just, the computer kind of glitch out so that or the algorithm, in this case, the AI kind of glitch out. But I asked it to create 16 images. It did create 16 images very quickly. And, most of the time it actually looked pretty decent, right? So, there's a question in the in the meeting chat that is it the same for text-based generation AI, and that's exactly the same, right? We are asking, and I'm actually going to talk about text-based in a little later on today, but that is essentially what generation of images, right? Image generation. So I have a couple more examples, and these are real examples. So I'm going to post this on in the chat here. You can all visit this site. this website. I didn't make this one. This website is called this person does not exist. Every time you refresh, it generates a brand new person based on its data set of all the people. So this AI was trained on a data set of people's faces, and so it's able to generate brand new faces of people, right? So that's one example. Basically, a very similar set of technology than what I have here, right? Similar set of technology. It's just that this one was created by this company called NVIDIA, and they have a lot of training data, and they spend months and months training this particular AI. Now, there's another question in the meeting chat say that is this video generation. Video generation is very similar to image generation, except that you're generating a lot of different images and then it can be put together. So another really cool thing, and I have another demo right here, this tab, right? So if you look over here on this tab, what we are doing here is that I'm leveraging one of the AI model called Stable Diffusion. It's an older version of Stable Diffusion, but Stable Diffusion is an AI that's trained on a lot of images, but it's also trained not only on images, but on text, on the caption of these images. So what this AI is able to do is I can give it a text description, and it is then able to generate an image of what my text description is. So my text description is a happy golden doodle riding a horse in space, realistic, with other spaceship. Let's see what this gives me, right? So that's what the AI actually thinks I am saying, right? So let's do another one, right? This is a simpler one. This is an older AI because I'll explain why I use the older version. I have a golden doodle, so a happy golden doodle in a boat, on a boat, on a boat. All right. So let's see what this does. Like everything's AI generated, right? So one of the question in the meeting chat is that Darren said that he broke it because there's a face with two eyes. Well, that's exactly what happened in these AIs. That generation is not always perfect. But here, a golden doodle on a boat, right? This is also AI generated, completely AI generated, right? Using one of the models that I didn't train, but I take advantage of, right? So it is able to generate images, and movies are essentially that. If I generate multiple images, then I can put it into a movie. Now there's going to be a lot more advanced techniques involved, but that's essentially what movies are, right? Is that generate images that look like they're continuation of each other, and there are techniques for that. So anyway, this particular type of AI that I'm showing you right now, this is called a text-to-image model. So this model called Stable Diffusion is what they call text-to-image model. It's able to take in a prompt, a text prompt, and it's able to relate this text prompt to an image, right? And is able to generate this image. So that's just a few different types of AI for now. Um, you will notice that here on this tab, what you're seeing here right now, right? This is the code to create this AI, but it's different than the one that I showed you earlier when we were training our little 4 symbols. And that's because to do this type of work, I need a bigger machine to do it, right? The one that train a classify system, I can use a not as powerful of a machine, but for doing things like Stable Diffusion or just regular generating images, I need a bigger machine, right? What do I mean by bigger machine? I'm going to show you here, right? The most important thing that I want you to pay attention to is this. I have what they call a GPU. GPU is the technology that allows these generative AI to work. Let me show you an example. Here is the same code, right? Here's the same code, but this machine does not have a GPU. You see this one does not have a GPU, right? This is the same code that I use to create the check mark. All right, so I'm just gonna run this, and then I'm gonna run the training. Remember previously when I run the training, it goes pretty fast, right? Take a look at this right now. If I were to do this 10 times, do you see how slow this is? Are you all seeing how slow this is? Right? That's because this machine does not have a GPU. It doesn't matter how fast your CPU is. You don't have a GPU, it's gonna take. Previously I run through 10 times this process, and each time is like taking like a minute, right, to run. While with a GPU, let me just show it to you right now. With a GPU, right? The training here, right? Same training. Like look at how fast this is, right? Each iteration is like a couple of seconds. So the CPU is very similar on both machines, but but because one has a GPU, it's running much faster. So generative AI would not be possible without GPUs. Right? The problem with GPU, of course, is that it's extremely expensive. Let's take a look at this one. Right, so this is the some pricing. This is, by the way, what I'm working on right now. So CPU is cheap, right? I'm using basically this one, 3 cents an hour, right? That's not that expensive. But if you look at GPU, you can see that let's go to GPU here. You can see that GPU. So the one that I'm using right now is I think it's called a T4, which is a cheap GPU. Is 42 cents an hour. And yes, these are what we call cloud-based GPU. I'm renting the GPU, actually. I didn't want to buy them. I'll show you why in just a moment. But here, this is like 42 cents an hour. But GPU can go all the way up to like this one, A100, right? This one is like 300 or $3.50 an hour. Now, what I want you to pay attention to, and Reza and the meeting chat actually pointed it out, is that these are all made by this company called NVIDIA. All these GPU are made by this company called NVIDIA, right? Because NVIDIA makes the best GPUs. So first, actually, let's go to the NVIDIA part there, and then I'm gonna come back to these ones because we're talking about NVIDIA. So let's take a look. Okay, so NVIDIA is basically the company that makes GPU, and they are the best at it. And you can take a look at their stock price for the last, ever since conception. You see this little what they call a hockey stick growth curve in their stock price, right? They went all the way onto look at the last couple of years. Can anybody tell me what? So this dip right here is kind of at the end of 2022. Can anybody tell me what happened at the end of 2022 that causes NVIDIA to go up, what they call to the moon like crazy? Right? Chat GPT, yeah. So this little peak is the crypto peak. And then right here, Chat GPT started appear on scene, and all the big companies realized that they need GPU to train their system, so that NVIDIA price has just gone way high, right? And it's still going up. I mean, this is like crazy. I wish that I bought some like somewhere over here, but I didn't. That's pretty sad. But yeah. But anyway, yeah. So now one of the question from the audience is that, so why not use why not use CPU? Why use GPU? So let's go back to and I'll try to answer that because I do have a couple of examples. Okay, so first, whoops, sorry. So first, let's take a look at that stable diffusion that we just looked at. The stable diffusion system, right? Now I want you to pay attention to this, right? It takes this A100 GPU to run, and look at the number of hours it takes. The one that we just used, literally the older model that we just used, right? Now let's go back to the pricing page just for fun here, right? It uses the A100, which is $3.50 an hour, and take a look at how many hours it took for that to train. It takes 150,000 hours to train the stable diffusion model that we use. 150,000 hours, multiply by $3.50 an hour, and that's how much it costs us to generate a silly little image, or to create a computer system to so that we can create a happy golden doodle on a boat. Yeah. Of course, it can create a bunch of other ones too. Like, you can create any image that you want. But I just want you to appreciate the scale in which these systems are built, right? Like, we built, a really simple system, right? Using very little resources. But these giant models, it takes a lot of effort, just in a hardware alone, right? And then of course you also have to pay for electricity. That's why I rent them, by the way, because if you rent them, then the electricity cost is part of this cost. But if I had to buy, oh, by the way, I want to show you how much one of these GPU costs. Let me go to the right slide here, because I love it when we are all asking questions, so that I can show you because I did prepare this, right. So this is how much the GPU costs. This is the latest GPU from NVIDIA, and this is in US dollars. So 40,000 US dollars, right, for one NVIDIA GPU. Now this is the latest GPU, there's one NVIDIA GPU. So I hope that you can all appreciate now why NVIDIA has this kind of stock price, right? It's because the resources that they have is just incredible, right? So very, very quickly, I want to explain why GPU is used, right? Very, very quickly here. So here now, for those of you who deal with images, right? Images are essentially a bunch of this particular animation. All I want to show you is that if you imagine like a 2x2 image, right? 2 pixel by 2 pixel image. Each pixel is actually a number inside a computer, right? It's what we call an RGB scheme, but essentially each pixel is a number. And what a neural network does is convert that into a formula. And you'll notice that this formula has a lot of multiplication, right? So each pixel needs to multiply by a variable, right? That's all that I need you to, all I want to kind of get across is that each pixel is essentially a number, and it has to be multiplied by this variable. So W1, W2, W3, W4, they are variables. But in AI terms, we call them parameters. All right. So essentially, in order to train an AI, we need to figure out these variables, these four variables. So for a 4 pixel by 4 pixel image, right, we create a formula that has four variables, and the AI algorithm essentially figure out some numbers that fit this equation. This is kind of like high school math, but it's okay if you don't it's okay. All that I want to you to appreciate is that there's a lot of multiplication that has to happen in order for an AI to work. Sometimes you see it looking like this, but this is what we trained just now, like for all of us, right? You provide me with a bunch of numbers, and I run through a bunch of numbers. I create an equation using this bunch of numbers, and the equation is created based on what Geoffrey Hinton, the Nobel Prize winner, has figured out. So there's this giant equation. This equation has a lot of what we call parameters. You can think of them as variables. So this little AI that we train, right, has about 500,000 parameters, 500,000 variables. So 500,000 multiplication that needs to happen in order for the AI to actually do any kind of prediction, right? Training takes even longer. So lots and lots of multiplication. So when you see the number of parameters, a lot of you, some of you may have seen this, right? Like, so GPT-4, for example, is estimated to have 500 billion to 1 trillion parameters. That's why these models take forever to train, and it takes a lot of energy to actually have them work, because they have so many parameters. Every time you ask ChatGPT to tell you a joke, it has to run through 1 trillion multiplications in order to tell you a joke. Right? And those trillion multiplication needs to happen really fast, because nobody's going to wait. And those trillion multiplications happen on NVIDIA GPUs, at least right now, as the time of this recording. And that's why NVIDIA GPU is so expensive. And that's why all the large companies, right, buy NVIDIA, and that's why NVIDIA GPUs or NVIDIA stock price is so high, right? You can look at just how many, like all of these parameters. And once again, you can think of each parameter as an individual multiplication that needs to happen when you ask a model to generate you a new word or a new sentence, and so on and so forth. Is that okay? All I want you to appreciate once again is the scale of these things, right? So just a simple little a model that we play with, right? It takes like so many parameters, um, and takes like 150,000 hours to train, and that's why what you see on the news is that Microsoft, which is an investor in OpenAI, which create ChatGPT, they are investing in nuclear power plant. Right, 3 Mile Island was a shutdown nuclear power plant. They are now restarting it because the power because we all ask ChatGPT to tell us jokes, right? When that happens, Microsoft or OpenAI requires a lot of power, right, to run through those run through those GPUs, and that's why we need nuclear power now. So just once again, right, it's pretty amazing how they all kind of come together, right? I'm not gonna spend too much. I know that we're getting to the close. We're getting to the end of our hour, so I'm not gonna spend too much time on this. But the latest development basically is all focused, right, on generative AI. And in generative AI, there are two types of generative AI that we use nowadays. That's the state of the art. One is called transformers. The other one is called diffusers. Now, I mean, this is referred to like, so if you allow me to just flash you some code here, I said that this is the most important part, right? This is what we call the architecture, right? So part of the AI algorithm is how you organize these parameters, basically, how you organize the equation. So one type is called transformers, and transformers are used for essentially large language models, right, like ChatGPT. Diffusers are used for image generation, and diffusers are what I showed you just now with Stable Diffusion, or the generation of a check mark. But transformers are the ones that are powering large language models. Now, I'm just gonna skip over here, and I want to show you how large language model actually look like. Large language models are essentially, and you have heard of this before, is what we call predicting the next word. You see here, all we are doing is predicting the next word. So if we wait until this jumps, right? So let's start with the quick brown. And then we run through the large language models, lots of GPUs, and it figure out that the next word, the most likely word is fox. And then quick brown fox gets appended together into one sentence, and then it asks, the large language model can predict the next word. So the next word is jump. So essentially, this is what large language models do. All they do is predict the next word. That's what we refer to LLMs. All right. Just like ChatGPT. So you may have heard of this, right? Oh, ChatGPT is nothing special because it just predict the next word. However, and this is something that so the title of this talk is Demystifying AI, but this is truly mystifying. Right? I'm actually not demystifying anything at all. Okay. This is a quote from this research paper from Google, because they do a lot of AI research. And you'll notice that the title of this paper is called Emergent Abilities of Large Language Models. And I just pluck out the abstract here, and I highlighted a couple of words. It turns out that when a word prediction AI keeps getting bigger and bigger, like more parameters and more parameters, and we feed it more and more training data, what starts out as a autocomplete, essentially, like these LLMs, they started out as autocomplete systems, right? When you type something, it try to autocomplete, guess the next word for you. We've all had that. Like we've had autocomplete for a long time, but it turns out that if you feed an autocomplete model, or feed autocomplete with a lot of data, and you increase the number of parameters to into the billions of range, right? Into the billions or even trillions, something truly mystical happen. And even the researchers don't understand this. You see here, there's this unpredictable phenomenon the researchers are calling emergent abilities, where because the number of parameters is so large, right, that it's now able to do things like pass the bar exam, like being able to do advanced mathematics, is able to create new recipes for you. it's it's essentially LLM is one of those things where nobody knew why it works. When you talk to ChatGPT, even the creator of ChatGPT, like OpenAI, even they don't know exactly why it works. All they know is that because they have a lot of money, they have a lot of NVIDIA GPUs, they have a lot of power. They just keep feeding this thing, like feeding a beast, so to speak, and then all of a sudden, the autocomplete seems to understand what you're saying, but nobody expected an autocomplete to understand what you're saying, but it kind of does, right? In many ways, if you have had experience with ChatGPT or any kind of large language models, ChatGPT is not the only one. OpenAI is not the only game in town. There are other ones available, and that's one of those things that we are going to explore, right? In my class, if you happen to take my class later on, like we're going to be able to explore some of those things. So yeah, I mean that's essentially what large language models are, right? One of those mystical things that nobody knew why it happens. Yeah. So finally, yeah. So I think we're at the end of our hour. But here are some of the key takeaways that I want you to come away with tonight. So first of all, remember Web and Mobile program at Langara, one of the best programs in Canada. I keep expanding, right? First I said is, in the city, then the BC, right? Then there's Western Canada. Now I say it's Canada. But anyway, so remember Web and Mobile program at Langara. But these are some of the major concepts and or some of the key terms I want you to take away. First of all is the idea of neural network. When something is a neural network, sometimes we also call it deep learning models. They essentially mean the same thing for the purpose of popular discourse, right? And these models, we have to train them first before we can use them. So that's the training part of it that takes a lot of power. And then there is the using them, which is what we call inference, which also takes power, but takes less power than training, right? Two types of AI right now. We're all focused on generative AI, but the same technology can be used for discriminative or classification AI. Understand why NVIDIA is there's a lot of interest in NVIDIA, even though they cost a lot, and even though their stock price costs a lot, their stock price still keeps going up, right? Because these large companies keep buying their GPUs, right? And then we kind of talk about, we have some demos on diffusers. We talk a little bit about LLMs, and we talk about emergent behavior. Finally, this field is so new that there are a lot of opportunities to participate, right? Like tonight, I just show you the behind the scenes stuff. But because because these large language models or these AIs have what we call emergent behaviors that even the creators don't understand them, I think that the future is pretty exciting because new field of study is going to open up, right? A lot of AI work has nothing to do with building the AI like I showed you tonight, but to test the AI, because nobody knew how these AIs are going to behave. So there's going to be a lot of opportunity in testing in a proper way, testing the AI, using AI in different ways, because even the creators don't know what are the best ways to use these tools. So there's going to be lots and lots of opportunities, I think, in the creative field, in scientific field, in business. I think there's just, I know that the people are saying that, some people say that, oh, AI going to take away jobs, and that may be true, but there are also going to be new opportunities that are opening up. So I really do think that it's something that's worthwhile to look at, which is why I'm pretty excited about them. In any case, I think I'm a couple minutes over. Thank you so much, everybody. If you have any questions, please do put it in the chat. I'm going to be, I'll hang around for a little bit. One of the question here is opinions on Sam Altman. Uh, um, Not so much. I mean, I think that Sam Altman, the founder, one of the founders, the business founder of OpenAI, he kept saying that, hey, these AI systems gonna become what they call artificial general intelligence, which is gonna behave like human beings. Based on the technology that we have today, it's not gonna actually. A lot of other scientists believe that artificial general intelligence is not, um like LLM is not going to be AGI, right? Like, there is, like, the technology right now, even though there are some emergent behavior, it's not going to be exactly, it's not the path to get there. But of course, Sam Altman being the business guy, he's going to keep, pumping it. Who knows though? I mean, nobody knew that emergent behavior would appear, right? So yeah. Well, thank you, everybody. Yeah, so I think that this particular session will be recorded, and I think that we will be posting them. And when we have additional sessions, I'm sure that we'll be able to post them. Yes, and connect with us. If you check the meeting chat, there's a lot of ways to connect with us on social media and everything.